Hey guys, my name is Puru and I welcome you all to this channel. In today's video, we'll be looking at the day 5 problem of the July Leetcode challenge, that is Reshape the Matrix. Now this problem, Reshape the Matrix, is an easy problem on Leetcode and is fairly simple to solve. In this video, I'll be going over two various approaches that you can use to solve this problem. Now let's look at the problem. So now we are given here a matrix of m cross n, and we need to transfer the data from this m cross n matrix into a new matrix of r cross c. Now we need to transfer the data in such a way that the sequence of the data is not changed. Also, we'll need to transfer the data keeping in mind if that new matrix is legal or not. And what makes a matrix legal is that if the amount of data that is already present in the original matrix is not changed in the new matrix, that is, no value is removed or another new empty value is not added. That means the size of the new matrix should be equal to the previous matrix. So this gives us a very good clue that the R cross C of the new matrix should be equal to the m cross n of the previous matrix. Otherwise, we'll just simply return the original matrix. So this gives us a very good clue that we can further use in our problem. Now, the very first approach that can be used is to traverse the matrix and store each element in an array. So we can just take two loops I and j, traverse it by row and column by every element, then store every element into an array. Then we can go over and that array and take every element from that and put it into the new matrix of R cross C. So now this is a very simple approach that you can use, and this will take the time complexity of m cross n. But also this will take the space complexity of m cross n because we are using an extra array. So the next method that I prefer to use is a method that does not involve any extra space. So let's look at that. So let's suppose that we have a matrix of size 4, 3. Now we have this matrix and we label each cell with the index that corresponds to that cell, along with the position we can give to that cell starting with 0. Now if you look closely, you can see a pattern emerging over here. For every cell, the row index is equal to the quotient of the position of that cell divided by the number of columns in that matrix. And the column index is equal to the remainder of the position of that cell divided by the number of columns. So this is a pattern we can see, we observe all over in this matrix, and this is the pattern, this is the formula that we'll be using to solve this problem. So now let's get into the code. So as I told you, we can eliminate many cases by just checking if the number of elements in the new matrix is equal to the number of elements in the old matrix or not. So we'll see. First we'll get the row and column count of the old matrix. So we got the row and column for the original matrix. Now we'll see if the number of elements in the new matrix is equal to the old matrix or not. Now if the number of elements is not equal, then we'll just simply return the original matrix. Very simple. Now there's another thing that might be possible. The row value and the column value of the new matrix might be equal to the original one. So if R is equal to M and C is equal to N, then we don't need to do anything. We can just simply return the original matrix in this case too. Now if that's not the case, then we'll need to have a certain integer that will be telling us about the position we are at, or the position of the cell we are working on in these two matrices. So we'll initiate two separate integers for that. Int n index for the new matrix, o index for the previous original one, while what this while condition will do is we'll run a regular loop until we have covered all the positions of all the cells, that is, we have covered all the elements of these matrix. Now we will be incrementing the position of our variables in each while step so that we can point to the next step. So we'll just simply write that statement over here. Okay, now increments done. Now we need to write the logic here. So as I told you, there's this formula that we can use. So we will take original, oh, I forgot to initialize a new matrix. Now let's look back at the formula we saw earlier. So this states that our row index is always equal to the quotient of position by the column of that matrix. So n underscore mat, that is our new matrix. The row value will be equal to the index, that is n index by c, because c is the number of columns in our new matrix. And for the column part, it will be the remainder, that will be n index mod c. So this will give us the column index of that matrix. Now we have to repeat the same thing for the original matrix, that was the previous matrix. So we'll go mat, we have o index for this one by n. In this case we'll use n because n defines the number of columns in the original matrix, and o index percent n. That's it. Now after out of this loop we'll just return n underscore mat. Now let's run this code. You can see that this test case passed. Now let's submit it. That's it. So that's it. Thank you for watching. If you want to learn more, subscribe, and I'll see you guys in the next one.